Hello everyone, and welcome to week 3 of Configuration Management, a short course presented by Information Technology Professionals Association, or ITPA. My name is Guy and I'll be your MC tonight, and your mentor will be Mike Ciavarella, who will be talking about planning, scalability, and integration and development. As always, please feel free to send your questions in via the chat function, and we'll answer as many of them as we can. Finally, I'd also like to draw your attention to a post in week 2's forum concerning participation in the forums. It relates to a change in IT Masters short course structure and policy, and should not affect any students negatively. Quite the opposite, in fact, I think. So yeah, have a look at that and familiarise yourself with the new way forward. For now though, please welcome Mike. We'll have a hopefully closer to 1 hour lecture tonight.
We'll try, Guy. Thanks for the intro.
Can't promise anything, of course.
Maybe we'll get a good spate of questions, and that'll take us to 1 hour and 2 minutes.
Yeah, well, I always say, let the questions come and we'll go for it.
We'll take them as they are.
Yep.
Hello, everyone, and welcome to week 3. A little bit of Administrivia before we get into the actual course content. Based on some feedback, I've been altering the exercises that I want to give to be less dependent on specific features of AWS. So it should be a little bit easier for those people who have chosen to not use not use AWS, but to use Azure or Google Compute Engine, to at least get a feel for what the exercise is. We also missed a little bit of content last week. I don't know how that happened, but there certainly wasn't time to cover it. So I'll prepare a separate mini webinar, and that will go up on the learn.itmasters.edu.au site. Today's class is talking about planning and growth and issues related to that. What do we mean by growth? Well, when we're talking about configuration management, growth typically means the number of managed nodes. We need to have a clear idea of what a managed node actually is. In the simplest possible terms, a managed node is a node that we have deployed policy to, or we will deploy policy to. In Ansible terms, it's a node that's covered in an inventory. That could be static, could be dynamic, it doesn't really matter. Now, that's usually what we think of when we talk about growth. It's the number of nodes that we're managing. But that's not the only aspect of growth that we need to consider. As we use our configuration systems more and more, the number of abstractions that we have in play will increase. Now, it's not obvious how many abstractions we will generally have in any particular environment. We'll start off with something simple. We generally will look at functional breakdown, a web server, a database server, and that's potentially 2 abstractions. But as you get into configuring more and more with your system, as you get into designing your configuration management for the best workflows, what starts to happen is you'll split your abstractions into more usable size. So you end up with configurations for a particular class of machine that are actually a composition, a set of abstractions joined together. And you need to manage that very carefully. We also need to think about how humans are involved with configuration management. The number of staff and number of groups that are working on a particular configuration management system can have a real impact on how that system is going to grow. If it is, it can actually limit the growth of the system. And it's generally really painful to find that you're limited not so much by the technology, but by the humans and the processes that the humans are using. We also need to think about the scope of coverage. The more we use configuration management tools, obviously the more coverage we get over our managed nodes. And that's a form of growth. And that carries with it great benefits, obviously, but there's also certain risks. As you become more dependent on this system, an error has a greater chance of propagating throughout all your managed node base. So you do have to be careful and aware of this. Finally, as we develop our config management systems, what tends to happen is we start by deploying occasionally, maybe once a week, and then once a day, and then a couple of times a day, until our processes are so well developed that we're essentially just pushing out changes as we make them. We may have some continuous deployment in place so that we're not manually triggering changes, but as a change goes through testing and acceptance, it automatically gets pushed out if it's a particular kind of change. So that's growth in the use of the system as well, similar to scope of coverage. There are certain factors that enhance growth. If your organization is more mature, you have a greater potential for growth. You need to be greater than the ad hoc maturity level of CMM. You absolutely have to be. If you're at the ad hoc level, you're going to get minimal benefits from configuration management. It will get there, but it will take longer to actually see change. Consistency, which is one of those things that you see in levels 2 through 5 in the maturity model, is really important for enabling growth. You need to have in place standards for how you're going to manage, write, and deploy your policies. You need to have standard processes in place. If you're an organization which rejects any kind of process, this is going to be hard for you. Ideally, you also want to have demand and feedback. Right? You want to have an organization or users or other departments who are pushing you beyond your current resource capability. If you have that kind of demand, it forces you to complete things. It forces you to get changes implemented as quickly as possible. You may not be able to do it all, but that demand will actually drive you, forcing things into your config management system because it's the only way you can survive. You need to also have the other side of that demand, which is feedback. When you do push changes out, you need to be able to measure the success of those changes critically. And if something hasn't worked or hasn't worked well, you need to be able to adapt it or eliminate it. Without all of these factors present in some respect, your growth will be quite slow. There are also inhibitors to growth. If you're in an organization which has poor risk management processes, if your organization likes to make up risks or use risk models which are inappropriate, for example, using a financial services risk model when you're selling hamburgers, this type of thing is going to make it really difficult to get approval and to get understanding of what you're actually trying to achieve with config management. It basically all reduces to, this is risky. If you get it wrong, we lose everything. For a lot of organizations, phrasing things that way will get you nowhere. What you need to do is look at the actual risks that are involved here. Treat this as a process. You're starting small. We're going to try rolling out configuration management in one very small aspect, and that's all. And we're going to sit on that for a couple of weeks, and we're going to see what happens. And then we'll try the next step and the next step. So what you're actually doing here is proposing and then following through with a controlled risk scenario. Small, bite-sized risks, which can be easily tested, low probability of failure. You're building confidence in or your management team, I should say, will have confidence built. There are practical considerations for a lot of environments as well. If you're in certain types of environments, configuration management is absolutely not going to be a problem until you get to devices that are managed or certified. In particular with medical and nuclear industries, they're all over configuration management, but once it's in, that's it, nothing changes. Right? They need to do that to maintain certification. In those environments, you're simply not going to get a new config management system deployed. There are also organizational growth inhibitors, and these are things that you're all familiar with, right? In particular silos across operational areas. You do not want to be in a situation where you're fighting with another team over which config management tool to use, or over who manages which machines, or even worse, who manages which aspects of machines with which tool. There's a lot of not invented here that gets in the way of config management. We already have scripts that do this, Mike. Why do we need to go and deploy a config management system? Right? Why do we need to change? It's not broken. These are all going to inhibit any kind of serious deployment of configuration management. When you start planning to either deploy or grow your deployments, there are some questions that you really need to ask. First of all, what are your goals? What do you want to achieve with this round of changes? It really does help to get into a long-term mindset with configuration management. Sure, you can get some quick wins, but you need to look ahead for where you're going to be in maybe 1 or 2 years of using configuration management. You need a roadmap. It doesn't hurt to write this down. You know, it can be a little bit pie in the sky, a little bit hopeful, but it does need to be there and written down. You need to figure out how you're going to measure and track success or failure. This is not a config management thing. This is just process and perhaps IT in general. You need good measurements, and we're going to talk about measurements for a large part of today's class. The reason you want measurements is for you to track success and failure, and for you to be able to show changes over time to your management, to the detractors for config management, and to the team. It's really good motivation to see that things are improving. Now, from a config management perspective, you want to understand what your key abstractions are going to be. And we'll talk about abstractions in a moment. You want to start thinking about what can be parameterized. This is kind of a part of abstractions, but you want to know what the actual variables are going to be. You know, I have a web server. Okay, great. That's my abstraction. What changes with that web server? Well, the parameters for that web server will probably be the sites it's serving. Web server A might serve sites 1 through 10. Web server B might serve the rest of the sites. Your abstraction here is a web server. Your parameterization is the set of sites. And you need to think about these things, because when you've figured out how you're going to represent your systems, the parameters are what's going to let you generalize your abstractions, right? Make your abstractions more useful across the board. You also need to figure out what systems, if any, you're going to need to work with. There may be a case, and it can be a bit difficult, there may be a case for having, say, Puppet and Chef running at the same time, but with different teams. You may have to interact with a system that you're expected to add users on, but the system doesn't have a modern web API. Right? These are all factors in planning for growth and planning for deployment. You need to at least make an attempt to understand what the answers to these questions will be. There are different types of measures that we can use. Now, I'm going to talk about some of them here. These are not the only measures that we can use to gauge how our deployment of config management is going. Okay, but they're a reasonable set to start with. The first type of measure we can use is based on inventory. We know the machines that we want to manage. So why don't we just look at the state of management of each of those machines? We can grade a machine as being unmanaged, or partially managed, or fully managed. I actually like to think of partial as really being two minor levels, a baseline level of management, which is the absolute minimum that we apply to any particular managed node, and then the actual partial management, anything specific to the applications that are running on that node. Another measure that's based on inventory is the average age of nodes. If you start getting large numbers of nodes, what you'll find is you have enough nodes to carry load, and it's often faster to just build a new set from scratch rather than try modifying one that's perhaps a little bit older. If you start to do that, then you can actually use the average age of nodes as a measure of success. The older the nodes are, the less you've changed them, which could be good from a static point of view, but probably not. The more likely they are to be up to date if they're young. You can also track the number of device types that you're managing. In large organizations which are formed through merging smaller organizations, you'll often find a very disparate range of equipment. By tracking the number of devices that you've pulled in under the control of a config management platform, you can actually get a measure of how much control you have over the entire organization's resources. It's pretty obvious. If only 10% of our devices are covered, well, we're at the 10% mark. You may never hit 100%. Not all devices can be managed with every config management system. You may have to find exceptions and allow them to stay as they are. But it still gives you an idea of progress. Now, it's important when you do measure that you actually consistently record the measurements you're making. Make sure you use the same counting method for consistency. And you need to think about how you're going to present these measures. Now, on the left of this slide, you'll see what you'd probably find in a typical management dashboard. Information is certainly there, but it's not particularly well presented. It's a stoplight. It's pretty clear that looking at this, all our Amazon, our AWS instances have some kind of management. But you have to stop and look and think about those numbers. On the right-hand side, you'll see, perhaps, maybe not, but perhaps a better way to present similar information by using proportions. Now, one of the annoying things about configuration management is you're generally doing this on the fly as you're growing the number of nodes that you're managing. So any measurement that you make needs to know the total number of nodes that you're talking about, because that's changing from under you. It's better to move to a dimensionless measure for presentation and reporting. Right? A dimensionless measure is just one where we've basically normalized. We've removed any notion of quantities or units of quantity. So a percentage or a ratio, basically, or just a plain number that means nothing other than in relation to other numbers. So in this case, I've used proportions, and just looking at those bars, you can see that the number of ad hoc managed nodes, i.e. the nodes that don't have config management running on them, is going down over time until you look at the number of nodes being managed. Now it's a little bit harder to see what's happening. I've included some extra ideas for you to think about in the slides, in the notes, sorry. This is a hard problem to solve. How do we present information for moving targets in a way that's easy to maintain and that shows us that we're getting somewhere? Okay. After inventory, the next type of measure is work-based. This is a set of measures that are basically going to reflect how much work you've had to do or how much less work you're now doing because you're using a config management system. The good thing about these measures is you may already have baseline measures, right? The number of tickets that each person clears in a week could be an example of such a measure. The number of outstanding tickets in total could be an example. The time to execute a particular class of ticket, right, to resolve that type of ticket could already be a number that you have. So if you look at applying work-based measures to your config management planning and growth preparations, what you'll find is you can actually compare config management to historical baseline. And that can be useful in getting commitment from management to take this further. The downside of this is if you're in an ad hoc environment, you probably don't have any real ticketing or tracking. It's all in email. So you're not going to be able to use that baseline. If you're in a managed environment or a defined environment or any of the higher levels of the CMM, you may well be using ITIL. There's generally a notion of a standard change, something that we do all the time. It has very low risk. It's basically pre-approved. The number of pre-approved changes should increase after you've started using configuration management because you will have proceduralized and reduced risk for changes that were previously difficult. Right? That's a good thing to have happen. You can track that. Perhaps the worst measure you can use is the number of incidents caused by or within your CM system. At least initially, that number will be high. There's a learning curve. And if you use that number and report it up to management, they're generally not going to understand that this is just how it happens. They're going to say, well, you made all these promises. They haven't been kept. We're not doing this anymore. On the other hand, if you've been running for 6 or 12 months and then you start to use this measure, you should have gotten rid of all those problem cases, and you can now measure against yourself every month how many incidents were resulting from the CM side, how many incidents were resulting from non-managed nodes. And you can track these over time. The third type of measure is policy-based. These are measures based on literally some kind of processing of your policy or the actions of the policy in the real world. The number of changes that a policy applies should be pretty consistent for the number of nodes that you have and each time you run them. If you have 100,000 nodes, you can expect a 1 or 2% failure rate. Of that 1 or 2%, most should be hardware failures. So you can actually separate out the hardware failures from the actual failures and track that number. If you start to do this for your baseline policy, what you'll find is something really interesting. That baseline literally allows you to track how successful your config management is, right? Because it's the baseline where you're going to get the most wins in that first year. If you start analyzing your policy and look at the number of roles, the nodes per role, the roles per node, that can give you some metrics. They're not going to be particularly useful initially. Again, after 6 or 12 months of running, these come into play. An easy measure to actually calculate, and one which is directly related to uptake of config management, is the number of logins on managed nodes. If you're doing this properly, that number should be quite low. On the other hand, if you find that even though you've got really good coverage with your config management policy over the functions of your machines, and people are still doing a lot of hands-on work, that's a problem, right? And it gives you somewhere to actually look for sources of the problem, which is a little bit different to the other measures. There are some other policy-based measures that you can also use. The number of failures per role, especially if you've got teams working on individual roles, is a reasonable way to measure how successful a team's training has been. It's not great, but it's reasonable. And obviously, nodes using a desirable feature, in particular with features that you had to switch off in the past because they've been problematic. The more nodes that are using these features, the more successful your deployment has been. Okay. Now, we do have a question block at the end, but I'd like to take some questions now, if we can.
Which I would gladly throw at you, but people have sort of just been happily listening, not asking questions at the moment.
No questions?
We've got a comment from Carl relating back to the planning and preparation. You were talking about what systems are you going to need to use and coexist with. You had an example of Ansible calling Puppet calling Chef, which runs a shell script. And he said, I'm not making it up. So all sorts of systems to consider then.
There are some weird, wonderful things there. One thing I have seen done with reasonable success is using Ansible to deploy Puppet. So you have a standard Ansible playbook. Its sole purpose is to bootstrap machines to be able to run Puppet. It's an interesting choice, but it's not a bad choice. The bootstrapping problem is hard, and Ansible solves that. And it means that you always have a fallback if something messes up in your Puppet config, which is unlikely, but it can happen. Then you've got a fallback. You can rerun Ansible, refresh your Puppet installation, and the next time everything runs, Puppet Masterd will do its job, and you're reconfigured, hopefully without the problem that you had previously. You can mix and match, but for consistency, I still tend to recommend that people stick with one system. It's far easier to learn and train and maintain a single system than two systems. Especially if it's systems that are as different as Ansible and Puppet. That's an overhead that you really don't want.
Alrighty, we'll have another question block in a few slides, so feel free to send them all in, folks.
Oh no, we do have.
Yeah.
I have a question from Vadim. What about baselining of systems in capacity planning? Baselining is easy, really. Once you've got that bootstrap problem solved, baselining is really just about getting a standard monitoring tool, performance monitoring tool on there. There are plenty out there. A lot of people use StatsD. And you just let it run. Let those machines run for a couple of days and build a baseline collection of stats. Capacity planning, I'm not exactly sure what you're asking, Vadim. I would guess that you're talking about factoring capacity into your config management planning. I think it does get back to just install that baseline set of statistics gatherers. Without that data, you're not going to be able to do capacity planning. It's that simple. You need to have good data for capacity planning. And it needs to be just a standard part of the system. It needs to be part of your baseline. You know, if you don't do that, then your capacity planning is basically guesses. In fact, it's, well, just more a guess than it normally is. Okay, we do have a follow-up for that. And what would I recommend to run under load or without load during baselining? I don't like, so I'll just interpret that question, Vadim. Do I prefer to baseline with the actual load or with no load at all? I prefer to baseline with the actual load. And the reason for that is no load doesn't actually tell me anything. It's a blank machine. You know, it might be running at 1 or 2% of CPU and, you know, 30 IOPS. Whereas, you know, if I run at least a close approximation of what will be on there in production, I get a better understanding of what I can expect. And that's not just for config management purposes, that's for monitoring and alarming as well. Okay, no problems, Vadim. I will take one more question because I'm having fun with questions. This is from Clinton. And the question is, how has Ansible grown compared to Puppet, Chef, and Salt? And if so, how much more development can be expected in Ansible? Well, they're all growing. Salt is perhaps growing the fastest in some respects, but that's also because it's the newest. Ansible is still subject to a lot of change. Puppet does change, more so in Puppet policy. The configs for Puppet, sorry, brain melted for a moment there. Chef is kind of growing in a different way. Chef have introduced a new product called Habitat, which attacks a slightly different set of problems, but complements Chef quite nicely. I can't comment on things like market share. I just don't know the numbers, Clinton. What I have noticed, though, is the number of playbooks that are out there hasn't slowed down in probably 18 months. It's gotten worse in some respects. There's now so much out there that it's hard to make choices a lot of the time. That's a good thing in some respects and a bad thing in others. Do I expect more development? I expect more development in all of these. You know, Ansible's changing slowly. You know, certain behaviors like default variables have changed with the move to version 2. You know, as we get better at using a particular tool, that feeds into the tool development. And Ansible developers listen. Puppet and Chef developers listen. I can't comment on Salt. Does that help, Clinton? I'll take that as a yes. Excellent. All right. Oh, okay. One more, because it's a really good question. Antonio has asked, how do we baseline hosts of different architectures, like Mac versus Windows versus Linux? You have 3 different baselines, and I know that's a very flippant answer, but the reality is each of those machines comes with certain things out of the box that the others don't. And so you're not really comparing apples and apples if you try and set them all to be the same configuration. But in terms of baseline, For each of those, you're going to have a concept of what software and what configurations and what settings you want a fresh machine to have. That's your baseline. It will be different for each of them, but the principle still stands. You should baseline each class of machine. It's an excellent question. Thank you. All right. So let's get back on to preparation and planning. If you've done any kind of formal software engineering, then the phrase quality attributes will probably be very familiar to you. These are the different ITs or ilities that we use when we're talking about software and complex systems. And it is possible to measure your CM quality in terms of usage and outcomes against each of these attributes. Right? You can measure flexibility and reusability. Right? That's a policy-based measure. You can look at how your policies are being written and how they're being reused and how they're being not used. And you can put a number on that. It's a little bit difficult at first, but you can do this. Right? You can actually gain some understanding of the quality of your policies. That's kind of neat. You can definitely use config management tools for security. That's a given. What you can also do is use the results of that as a measure of compliance. So for example, if you're running a PCI network that has to meet PCI requirements, and you're using configuration management for the technical side of that, a successful run without changes is a really strong argument to an auditor that you're in compliance. Similarly, if you can push out patches really, really quickly, so you measure the time that you received a patch to the time that patch was approved and applied across your entire fleet, that is a really good indirect measure of your security posture. Right. These are both work-based measures, obviously. You can do some static analysis of your policy to measure how consistently it's being applied and how maintainable it is. There are linters for the different configuration management systems. Some of these can be integrated into your editor. Others you can, or the same ones, and others you can run in your config management, in your continuous integration system. So we spent a lot of time last week looking at Jenkins as an example, because Jenkins is a really good example of configuration continuous integration. It just so happened that that policy, that playbook was available, and it was a reasonable example to work through to get a feel for Ansible playbooks. There are other quality attributes, right? These ones are easy to measure: efficiency, performance, and scalability. How quickly does a particular set of plays get applied in Ansible? Okay, record that number. Over time, those plays should take less time because most nodes will already have those configurations. You graph it, you should see the time going down. On the other hand, as you scale up, the time should go up initially and then come down, so more like a hill-shaped graph. You can also measure reliability. How often do my policy applications crash? Okay, none, that's great. Once every 10 runs, not so great, but at least it's measurable. Okay. We've lost, there we have it, there we go. All right, so in summary, you need to get these measurements decided on early and even set them up before you start writing policy. State your objectives, write out a roadmap, right, and think about all of these measures. Plan for ultimate success. Ask yourself, will this work if I've got 1 million servers? All right, now plan for ultimate failure. Will this work here in my environment? Over time, what you're really trying to do here is get a set of meaningful measures that you can compare. You can have a historical record of how effective or ineffective configuration management has been in this context. And don't be shy about talking to management here. Right? Figure out how your management determines and measures success. Right? And make sure that your measures can feed into that process. If you believe in configuration management as an effective tool in your environment, this is not going to be a hard sell, but you are going to have to do a little bit of selling, and you need to be able to speak to management on their terms in their language. Right? So build your measurement systems to be able to feed to management. We rolled out 100 new nodes. It used to take us an hour a node. It now takes 15 minutes, and all of that time is putting it in the rack. Management like to hear that kind of thing. Okay, so we talked about abstractions last week. Abstractions are really, really important for growth. If your abstractions are coarse, if they're large general abstractions, well, they're not actually that general, they're too general. The implication here is that your policies will be large, and large policies take longer to apply. They take longer to determine the state that your node is currently in. And that can slow things down, right, to the point where it's just impractical to be running those policies. On the other side, if your policies have too fine a granularity, right, they're too specialized, the amount of reuse you'll get is too low. And less reuse means less scalability. You need to worry about the dependencies between your abstractions as well. If you have tightly coupled abstractions, that's basically the same as having coarse granularity. Except now, because those abstractions are tightly coupled, they're tightly dependent, the amount of parallelism that you can apply, right, the number of things you can do at once is significantly reduced. So deploying with those abstractions becomes problematic. You've also got human limitations. If you get the abstractions wrong, too coarse or too fine, then humans won't understand what's happening, or they'll be overwhelmed by having too much, especially if they're new to the system. Right, so there's a big juggling act going on here. You have to try and get it right. And accept that you'll get it wrong initially. As you get more experience, you'll understand what works best in your environment for that tool. The typical abstractions that you want to start thinking about are things like, your common or baseline policy. Functional abstractions. What does this machine actually do? Is it a web server? Is it a mail server? Is it a user's workstation? Is it a user's workstation that can run extra piece of software X? Should I be abstracting with a geographic basis? Think in terms of data centers. do I want an abstraction that allows me to target everything in one data center? It's probably not a bad idea in a lot of cases. An even better idea would be an abstraction which breaks a data center down into reasonably large groups, so that you can address each group separately, or you can address the data center as a whole. Right, for those people who are familiar with AWS, we're talking AWS regions and availability zones within the region. Do I want to abstract based on platforms? Probably. But should those be hardware or software platforms or some combination? That's going to depend on your organization. If you think of your nodes in these terms, you can start to do things like automatically incorporate a node's IPMI or its BMC into your monitoring system. And that's kind of neat. It means that you literally just have to plug a machine in and things start happening on that machine. Do I want to abstract with service objectives? This is a highly available cluster. This is a resilient but not highly available cluster. This is version 1. Version 2 is managed differently. You have administrative domains. These are natural in most organizations. Do you want to reflect these administrative domains in your abstractions? Sometimes the answer is yes, and that might allow you to actually have different groups managing different abstractions. If you take that too far, you'll end up with silos. And generally, the IT people that I talk to aren't huge fans of silos. They don't often work at all. You may also want to abstract based on activities. This is something I do a lot when I'm using Ansible. And I've got some notes in the handbook about that. I abstract based on an initial setup, some software changes, and BAU or day-to-day changes. And the reason I do that is that way I can run the BAU changes really quickly. It's a subset of the playbooks that I'm using. Because it's a subset, it runs much faster. In fact, I can run that every couple of minutes, and I can force those systems to be managed faster than they were before. And this is without introducing any continuous deployment. Continuous deployment just removes the human from the loop. Right, so here's one example of an abstraction plan using Ansible. Every node has the common role. Absolutely every node. What that means is when I have varied platforms, that common role will shrink. To account for those varied platforms, what I'll actually end up doing is having a sub-role for the operating system, for hardware. So I'll still say every node has a common role. That's the human understanding. But the technical implementation is that common role has a very small core, which absolutely everyone uses. And then it has specifics based on the platform that it's running on. Every production node gets one and only one of the web server, mail server, or DB server roles. I'm deliberately saying my abstraction here is functional. Web server, mail server, or DB server. I then add an extra role. I say every fifth web server also acts as a reverse proxy. Now, there are different ways to implement this. It depends totally on the config management system you're using. I've given you an Ansible example, but the same principles apply no matter what config management system you're using. You need to get these abstractions right. Okay, let's take some more questions.
Yes, folks, let's send in some more questions. We're a bit quiet tonight.
I've just noticed a question from Ian. Have we talked about automating the patching for WannaCry? That's all we've been doing since Saturday. No, we haven't, and it's an ideal use case. But I'm going to just answer with a small amount of philosophy, which is intended as sarcasm. I do want to say that now. But if you are running internet connected machines and you've opened up your SMB ports, perhaps this is your wake-up call. And yes, I know there are people who are on internal networks and are having problems. You do have my sympathy. Has Ian left, or has he come back?
Can't see that one.
It's okay.
Timothy's asked, he's still here. Thanks, Ian. With week 2, we set up the VM and Amazon EC2. Will we be using these at some point, Timothy?
Yes, you will. You'll be using them for week 3 and week 4.
Wonderful.
I have not got the lab part of the exercises out yet for week 3. I hope to do that in the next day or so. And yes, I wouldn't make you do it just for the heck of it. We both have enough on our plates, Timothy.
All righty, what do you reckon? Head on to the next bracket?
Yep. Alrighty-o. Let's move back to here. Okay. So it's a little bit hard to talk about scaling meaningfully if you haven't got config management in place, but we're going to give it a try. There's a bunch of factors that play into scale for config management. The obvious factor, again, is the number of nodes that you're managing. As you scale out, as you grow the number of nodes that you're managing, certain things start to happen. You need to worry about consistency. And that consistency is going to be an ongoing problem. With large numbers of nodes, stuff will fail. So you'll try to push out policy, and out of 100 nodes, 2 might not get it. So you've now got nodes in 2 different states. And if those 2 nodes come back up and run in a different policy state, that may be a problem. You also have the situation that not all nodes will apply policy at exactly the same time. There's a certain latency between when a node retrieves a policy and when it applies a policy, and that latency differs across your entire set of nodes. So you need to make sure that your policies aren't dependent on simultaneous update. Next week, we'll talk about orchestration, which attempts to solve that particular problem. The number of masters in your system also becomes a factor. As you scale out, the number of nodes increases. It's entirely possible that the number of nodes will overwhelm the number of masters that you have. Now, in particular, if you're running a push system like Ansible, there are limits within the operating system, certain system limits, number of sockets and so on, that limit how many machines one master can control. As well as that, on Ansible, in particular on Ansible, the master decides what policy goes out to the nodes. So that's a computational load that acts to constrain how many nodes a master can manage. So the obvious thing to do here is increase the number of masters. Now you have a problem with synchronization. Which masters are going to talk to which nodes? And how do you know that all of the masters have the same policy and that they're pushing that out? Now, if you look at a pull system, such as CF Engine, synchronization's less of a problem. Peak load is less of a problem. Resilience, it's still a problem. It's easier to have multiple masters if you get the synchronization right. Sorry, we're having little tech issues here. Apologies. You may hit limits within your CM tools. These are limits like the one I just mentioned with Ansible and the policy decisions. A particular tool may only be able to run so many parallel connections from clients at once. It may be written in a language which is great for maintenance, but is poor for performance. These are all factors that you need to be aware of as you scale out. All of these systems work absolutely fantastic for less than 100 nodes. So when I'm talking about scaling out here, I'm talking about thousands of nodes. That's where you start to hit problems. You hit them earlier with Ansible in particular, but generally it's in the thousands where you start to hit real issues. The other thing you've got to be aware of is there are just natural limitations in the way we build these systems. Fan out refers to the number of devices one device connects to send data. As you fan out, you'll hit limits within the sending machine. If you have fan in, you hit limits with the receiving machine. So, a machine receiving from 1,000 devices at once. And the actual design of your systems comes into play in a similar way here. If you have a web proxy, a reverse proxy, that has web servers as its dependent, and you don't have a duplicate of that proxy, then you have to be very careful about how you scale. It's entirely possible that you'll break something, and whilst the policy will result in it being fixed, because you've got so many extra nodes, that time to fix may be on the order of minutes. The types of problems you're going to see is how long it takes to distribute your policy. You make a change, you've got 100,000 nodes. It takes time to get that policy to all of those nodes. Right? That time may be small, it may be quite large. You've then got to worry about the time to actually apply the policy. If you're running an agent, it's just not a problem. It'll happen when it happens. On the other hand, if you're agentless, your controlling node, your controlling machine, will take time to apply policy. And that's going to affect how many nodes get that policy in a particular unit of time. You're also going to have problems with policy consistency, right? Across masters, which we've already talked about, across nodes before it's applied, and as it's applied. Again, remember at scale, we have all these little things breaking just because of the sheer numbers we have. Not everything is going to be running at once. So you're going to see machines that you can't connect to, machines that you can connect to that won't correctly apply. I have a little mantra that I use. It's a variation on one of the Google mantras, but at scale, everything fails. It doesn't matter how resilient it is. As soon as you have lots of them, you have enough that something will fail. All right. So let's say you have configuration management in place. You've got a couple of thousand nodes coming next week. Where are your problem points going to be? The first thing to do is draw out your configuration management processes. Understand the flow. The way I've drawn this, it's just a nice, simple process. And I've put down all the gates, everything that needs an approval or something to happen besides moving some data around and waiting. There's 7 of them. And this is a reasonably standard configuration management process. Each of those gates represents a point that's going to affect your scalability. Does anyone have any disagreement with, and I'm watching quite closely here, can everyone see that at each step you have to worry about how that interaction, that interface will scale? It's really hard to explain this concept. All right, I'll assume people will ask questions as we're going through. We'll just do one example. The first gate is the way people work on policy. This is not a CM process specifically. This would be, people working in the same Git repo and how they manage conflicts. The second gate is what Git does to minimize conflicts. Now, as you scale the number of people, the problems with merging and conflicts increase. As you scale the number of projects you're working on, those people are working with, the work that Git has to do goes up as well. As you increase the number of projects, we get to the third gate. The config management, the continuous integration system needs to deal with more continuous integration, right? And it just goes on and on and on. And each one of these points is a point that's going to be a factor in scaling out just the number of nodes. All right, that's what we've spoken about. People are an important part of scalability. There are different things you can do to deal with the people issues when you're scaling. Right? There are technical areas you can work in. You can mess with abstraction. You can split your policy up. You can split your inventory up so that this team works on this subset of the inventory. One thing you should definitely do is have standardized training and induction so that everybody's on the same page. When you do have problems with scaling then, you won't have to spend time bringing people up to speed. You can also scale how people work within your config management processes by using the old tried and true of separating concerns and making sure that there are clear demarcations and handovers, which is a very polite way of saying silos that talk to each other. You can also attack particular parts of the process. In particular, if you're using continuous integration, continuous deployment, you can set up dedicated pipelines to enforce particular standards and to allow certain changes to roll out faster. Splitting those pipelines will mean that you need more resources. However, the resources that you are then using don't get in the way. Right, and finally, if you've got people in the loop here, please communicate. IT people are meant to be notorious for not communicating. My experience is different. We tend to have our egos, that's all. I'm going to skip this just question set because we've done a few. Just quickly wanted to look more specifically at continuous integration, continuous deployment. I get asked the question a lot, if I have continuous deployment, do I have to have continuous integration, and vice versa? And can I separate the two? This is the way I've always thought of continuous deployment and continuous integration. They're linked at integration tests, and you have an option to deploy. You don't have to take a deployment, right? But the option is there. The main part of this is actually not the deployment. It's the continuous integration, right? It's making sure that you have a process for code in your repo getting processed by the CI server, running its linters, running its unit tests, setting up integration tests, putting things into containers and testing them, right? And then when you're happy, record the statistics and make a decision on deployment. It's a pipeline. It's not particularly hard to understand. There's a lot of effort in setting it up. Yeah, when it comes to scaling, these pipelines will become part of your configuration management workflow. And they're usually a pretty good candidate for optimization. So standard principles apply. Keep things as simple as possible. Fail early. You want to build to fail early if you've got continuous deployment happening from that as a result of that build. You don't want to deploy broken stuff. If you're not doing continuous deployment, you actually want your pipelines to give an early indication of failure, but to run as far through the pipeline as they can for efficiency. Right? That way, somebody will know that something has failed, and instead of just getting 1 or 2 bugs, they'll get 30 or 40. Having multiple pipelines helps you achieve that. All right, so now we have real questions.
Yes, and we've got a few.
Okay.
Woohoo! So Tony, I'll take you back to the scalability graphic. I was wondering why there would be a gate.
Which one?
Or pause. That one, yeah, that's the one.
At monitoring?
Yeah.
All right, so there's a gate on monitoring. What happens is your nodes apply a change, and there's definitely a time taken there, a gate or a pause. Your monitoring also takes time to determine status. Right? You can't know if you've got 100,000 machines. You can't know that at this exact instant in time, all of them were running or all of them weren't running, or anything in between. You can only know within a certain resolution of time. And that resolution of time, as you scale up, becomes quite significant. Right? The same problems you have in how many masters do I need also apply to monitoring. There are tricks. You can have a monitoring system which uses a pub sub bus. There are still limitations, but they're just less obvious.
Okay, thank you. Gino has sent in a question. Can CM tools such as Ansible, Puppet, Chef, etc. Cater for network usage throttling?
For network usage?
In other words, avoiding situations where small, remote, low bandwidth sites might become saturated during an organizational wide change that might distribute a number of sizable package software changes.
Okay. So what I believe you're asking, Gino, is can these tools allow you to pre-stage changes? And the answer is kind of. What you can do is you can use, for example, tools which allow you to say well, I'll give a specific example. Let's say you have a dozen sites. You have very small links between those sites to a central hub, and you need to push out a gigabyte of packages for an update. If you're running that type of site, you'll generally have a local server or a local resource that you can push those files to. What you would almost certainly do is break that process out, because it's an exception. It can be managed within CF Engine, Puppet, and Ansible, but because it's going to take time for those files to transfer, you don't want them sitting around waiting. So you'd probably write an rsync script, limit the bandwidth that's being used to a percentage, and run that script during the day, and then at night when things are quieter, use more bandwidth. Eventually those rsyncs will complete, and at that point you can then apply the playbook.
Cool.
What you need to do, I'll just follow that up a little bit. You need to make sure that your system design allows for that type of change. Now, if you need to reboot 20 machines and reinstall Windows on those machines, you're going to need a machine there that is able to hold a Windows installer image, or a RISC server or something like that, and act as the local server. You're not going to run those over a wide area link.
Super. Jasper's asked, given we can implement the best and most secure configuration management in an IT infrastructure, we can't account for the greatest threat, which he thinks will be internal users. How do we manage that threat?
So Jasper, I'm honoured that you think I can solve the human problem, but I don't have a
question session, folks. It's Stump Mike.
I can give you some things that I've seen work and things that I've seen not work. The first thing you really have to do with your users is set expectations, and be clear about those expectations. I've been at sites that had a very clear policy of, we do not allow executable attachments in email. And they had management who had decided that that was not appropriate for them, because they wanted to receive certain files as executables. And so the policy decision was made that users could apply to have that limitation lifted, but they would have to have a signed agreement to cover the costs of any viruses introduced as a result. And the fear of that generally stopped people at least sending things in by email, and instead push them to using USB sticks. So there's a saying that you can build a system to be idiot proof, and humanity will just build a better idiot. It's a little bit negative, but
I like it.
It's unfortunately quite true. I'll just back to expectations. If users understand what they are and aren't allowed to do, and I mean genuinely understand, don't say you can't change this registry setting. Just be very clear. Only company-owned software can be installed on these computers. Please don't ask to install private software. And keep the expectations clear and simple. A lot of problems go away. It's far better to regulate than to ban, I suppose. I had one customer who Didn't have very large budget, didn't have very large internet link, and they had users who persisted in using internet-based radio to the detriment of the organization as a whole. They weren't all listening to the one station, they were all listening to their own individual stations. And so the policy went out that limited internet radio would be allowed, but that it would be managed as a resource. And then we simply chopped down the bandwidth available, set a fixed bucket for that bandwidth. And what happened was the users actually coordinated amongst themselves to pick a smaller number of stations that were then multicasted out. So, users aren't stupid, but they do need to know their expectations, or know the organization's expectations, and that gets rid of a lot of threats. The people who are sending phishing emails and so on are getting very, very good. And, I think you just have to accept that, unfortunately, people are going to make mistakes. Don't blame them for it. It's not their fault that someone from a spam house has broken through. Sorry, I can't solve that particular problem. I hope it helps.
It sort of reflects Ed's comment following the question. It helps to provide a pathway for them to get what they want, not just a no.
Yes.
We've got a question from Antonio, who remembers that there was an ATO web crash. He's wondering how we avoid similar scalability problems and which gate to fix.
All of the gates, Antonio, all of the gates. You need to design your systems on the assumption that things will fail. So let me. What time is it? Okay, let's officially call this closed, but I'm going to keep chatting because I'd like to give Antonio a quick answer. A little bit of philosophy. There's two ways to approach resilient system design. One is to say, here is my system, what do I do when it fails? The other approach is almost exactly the opposite. My system has failed. What do I need to do to restore it to a running state? Now, if you take this to an extreme, in one case you start off with a blank piece of paper, and that's actually a system. It's just not working. And you start asking yourself, well, what do I need to get this system working? And so you essentially have a system which bootstraps itself. You can also sit down and say, well, I need a web server. To make that reliable, I'll need 3 web servers, some kind of load balancer, some kind of load distributor, maybe a router and a this and a that. And so what you wind up with is systems that have both been designed to similar goals, but with a very different approach. It's easier if you've got no system in place now. I don't have specific access to the ATO issues. However, one thing I have noticed with a lot of the public government crashes is there are certainly things that could have been done differently, and there are generally organizational reasons why that wasn't the case. These aren't technical failures, they're organizational failures.
For example, the what was it, the census?
Yes, the census. Yeah. So yes, let's just not, because I promised to try to keep this as under the 2-hour mark.
Right. Yeah. Sure.
Do we have any other questions?
No. Antonio says thank you, and I might just say thank you everyone for coming in again this week. Next week we'll have some information about the exam as well as the presentation, so don't worry, we'll make sure you're in the loop. Thanks very much, Mike.
Actually, I do want to say one other thing.
Yep.
I'm really impressed by the discussions that are happening on the forum. Really, really impressed. Thank you, everyone. It's actually making my life a little bit easier because you're giving me ideas of things to merge into the slides. Oh, speaking of slides, there was a question. Oh no, that was last week. Okay, excellent. All good. I'm done.
All good. You're done.
Yes.
All right. Well, thank you.
Thanks,
thank you, everyone, for coming. Yeah, thanks, Mia, as well. We'll catch you all next week. Same time, same bat channel.